Good morning, students. Today we are going to start our new chapter, which is chapter number 1, mathematics for class 9th, and which is number system. So before we start, we have already studied this chapter or this number system in our previous classes. Tell me one thing, what do you mean by natural numbers, or what are natural numbers? We can also say that natural numbers are nothing but the counting numbers. So tell me, what are natural numbers or counting numbers? So natural numbers are those numbers which start from 1, 2, 3 and goes up to infinity. What if I add 0 in the series of these natural numbers? When we add this 0 in the series of this natural number, the whole series become whole number. So from 1 to infinity, we have natural numbers. If we added 0, it become whole number. The symbol for natural number is capital N. The symbol for whole number is W. What if I add some negative non-decimal or non-fractional number in this series? Like -1, -2, -3 goes up to minus infinity. Now what did it become? So now these numbers are integers, denoted by capital Z. So likewise, we have many other types of numbers in our number system chapter. So let us start this chapter. What we are going to cover in this chapter? So write down the topics which we are going to cover in this chapter are: the first topic is introduction to this number system or types of numbers which we have. Then we are going to cover what are rational and irrational numbers. Rational numbers are denoted by Q, irrational number denoted by I. Then we are going to cover the next topic which we are going to cover is how to plot irrational number on number line. After this, the topic which we are going to cover is conversion of rational decimal number into fractional form. Or to convert decimal rational number or terminating or non-terminating but repeating number into P by Q form. After this, the topic which we are going to cover is rationalization, then we have laws of exponent. Again, you have already studied this laws of exponent in your previous class, so it must be very easy for you all. And then we are going to solve lot of questions from our worksheet. We will try to solve some questions from worksheet side by side, but after completion of this chapter, we are going to solve some whole questions from our worksheet provided by our school. And then you have your test after the end of this chapter. So let us start with our first topic, which is introduction to number system. Let me rub the board. So what do you think? What type of numbers we basically have? So in starting, we have two basic type of numbers. First are non-decimal numbers, and second type is decimal form or decimal number. As you can understand from the word non-decimal and decimal, in non-decimal numbers there are no decimal or fractional form. So what type of numbers are going to become in this type? There are three basic types which we have already studied. The first one is natural number, or we can call them as counting numbers, because natural number are generally used for counting, like we have these decks in our class. So we can count 1, 2, 3, 4, likewise 44 decks in our class. So we are using natural number for counting. That is why we call natural number as counting numbers. We start from 1, 2, 3 goes up to infinity. After this we have whole number denoted by capital W. Natural number are denoted by capital N. Now what are whole numbers? So whole numbers start from 0 and then 1, 2, 3 goes up to infinity. So we can summarize this whole number as whole numbers are natural numbers containing 0. Whole numbers are natural numbers containing 0. So these are whole numbers. And then we have integers denoted by Z. This integer is further divided in 3 types, which are negative integers, which denoted by Z minus, zero integer denoted by 0, and then positive integer denoted by Z plus. Negative integer contains all negative natural numbers. Why I am saying this as negative natural? Because we have negative sign with natural numbers. -1, -2, -3 goes up to minus infinity. In case of positive integers, so positive integer are nothing but purely natural numbers. And what is zero integer? So zero integer is itself 0. We have already studied these 3 types in our previous class. Now let us come to next topic, which is decimal number or decimal form. We also call it as fractional form. Now these decimal numbers are divided in 2 parts. The first one is the rational number. You have also studied this particular type of rational number in your previous class. What are rational numbers? Yes, so rational numbers are basically those numbers which are in the form of P by Q, where Q should not be equals to 0. But now we have 2 more definitions for this rational number, particular rational number. The first definition is, which we are going to use in this first chapter, the first definition is terminating numbers. What are terminating numbers? So as this word is defining, terminating means which can be end or terminate. Asan bhasha mein, suppose we have 1 by 2. We have fraction 1 by 2. If we try to solve this 1 by 2, we will get 0.5. Means after point we get only one decimal, means we get only one place after decimal, which means that the number gets end. So such type of number are known as terminating numbers. Means terminating numbers contain 1 by 2, 0.25, means all those numbers which get end after some point of time or after some places. Second type is non-terminating but repeating or recurring. Now what are non-terminating but repeating numbers? So let me take one example. We have 1 by 3. If I want you to solve 1 by 3 into decimal form, 1 by 3 is basically 0.333 ... Means after point 3 is coming again and again. We can write this continuous form as 0.3 bar. इसको मैंने कैसे याद किया था? Since 3 is coming again and again, ये बार बार आ रहा है, so we put bar over 3. So we write this 0.3333 as 0.3 bar. Similarly, we have many more numbers, like we have 22 by 7. If you try to solve 22 by 7 or try to convert this 22 by 7 in decimal form, you will get 3.142857 142857 ... Means after point 142857 repeating again and again. So you can directly write it as 3.142857 bar, because 1.142857 coming again and again. वो बार बार आ रहा है, इसलिए हमने उसको बार के नीचे डाल दिया. So 22 by 7 is nothing but rational number because it is non-terminating but repeating. ये point याद रखना. We are going to do some question based on this 22 by 7. After this rational number, the second type which we are going to cover is Second type is irrational number. Irrational number. Now what are irrational numbers? So those numbers which are non-terminating, non-repeating. Numbers which are non-terminating and non-repeating. Such numbers are known as irrational numbers. Irrational numbers are denoted by capital I or capital T, whereas rational numbers are denoted by capital Q. These are the symbols for these type of numbers. So let me take some example of irrational number. The first irrational number we can write as root 2. Root 2 is an irrational number. Why it is irrational? Because if you are going to solve root 2 using long division method, the number comes out to be 1.4142 dot dot dot, which means after point number is neither terminating, means वो end नहीं हो रहा, non repeating, ना ही वो end हो रहा है ना ही वो repeat कर रहा है. तो such type of number are known as irrational numbers. Some more examples for irrational numbers. Class, you tell me some more examples for irrational numbers. So some more examples are root 3, root 5, means all those prime numbers which are under root are known as irrational numbers. Root 3, root 5, root 11, root 13, these all are irrational number are examples. So after covering this topic, let me ask some questions from you all. Tell me one thing. Can I say that all natural numbers are part of whole number? We have studied three types here: natural, whole and integer. So tell me class, all natural numbers are whole numbers, yes or no? So yes, all natural numbers are whole numbers. Tell me, all whole numbers are integer? All whole numbers are integer? Yes, all whole numbers are integers.
So integers are negative also?
But all whole numbers are integers. All integers are not whole. Am I clear to all? So for this, I have a very good concept for solving such type of question. You can simply learn this circular concept, which is the smallest type is natural number. After this we have whole numbers, means all natural are part of whole, and then we have integers, means all natural or all whole numbers are part of integers, and then we have rational or irrational. Why I write this rational and irrational in the same circle? Because two rational number contain infinite irrationals, whereas two irrational contains infinite rational numbers. And then what we call all such numbers, or all such numbers come under which concept? So always remember, the grandfather of all numbers are real numbers. Means all such numbers which are going to be plotted on number line, whether it is natural whether it is natural, whole number, integer, rational or irrational, all such numbers are nothing but real numbers. So now we are going to solve some questions from our worksheet. We are going to solve some questions from worksheet. The first question from our worksheet is state true and false and elaborate your answer. The first question is, the number root 2 is rational or irrational? In your worksheet, the question asking is whether root 2 is rational or irrational. As I told you, the value of root 2 is non-terminating, non-repeating, therefore root 2 is irrational number. Second, in second part, the question is, the decimal representation of the rational number 3 by 4 is. What is the decimal representation for number 3 by 4? Or how you are going to convert 3 by 4 into decimal number? To convert 3 by 4 into decimal, we have two ways. The first one is to divide 3 by 4, and second or different method or second method is, you can try to convert the denominator in terms of multiple of 0 or multiple of 10. we can directly multiply this 4 by 5 multiply 5. Why 5 multiply 5? Because 5 5s are 25 and 25 4s is nothing but 100. Since we have zeros in denominator, so we can directly put point in place of zeros. So as we multiplied 5 multiply 5 or 25 in denominator, so we have to multiply 25 also in numerator. Now it directly become 25 3s is 75 divided by 25 4s are 100. So we can directly put point before two digits. Now it becomes 0.75. So decimal expansion for 3 by 4 is nothing but 0.75, and our second part is true. Third is the number pi is a rational number or irrational number. Class, you tell me. Pi is rational or irrational?
Sir, irrational.
Okay, pi is according to you, pi is rational.
Irrational.
Pi is irrational. Okay. Let me tell you the concept behind this. What is pi? If I want to ask what is pi, so pi is nothing but the relation between circumference to the diameter of a circle. Circumference to the diameter means we have, suppose we have a circular watch in our house or a circular clock in our house. If I try to find circumference of that clock and divided by diameter, we get the value of pi. And we can continue this process with any circle in our world. किसी भी circle को उठाओ, try to find the ratio between circumference to the diameter. You will always get the same constant, that is nothing but the pi. And the value of pi is what? This is 3.14 ... Dot represents this number is neither terminating nor repeating. So this means pi is an irrational number. But as we know, or we consider in our previous class, the value of pi as 22 by 7 or 3.14.
But sir, here you are writing this as an example of rational number. It is repeating 22 by 7.
Yes, as I wrote 22 by 7 as an example of rational number because the value of 22 by 7 up to 2 decimal place is 3.14. And similarly, the value of the actual value of pi up to 2 decimal place is nothing but 3.14. Since both are same, so we generally take approximate value of pi. Means 22 by 7 is not actual value of pi. It is approximate value of pi. This is sign of approximation. Value of pi, approximate value of pi is 22 by 7 or 3.14.
So this value we are taking while solving the questions?
Yes, ma'am. Yes, friends. We are going to take 22 by 7 or 3.4 just for our reference. Just try to find answers. So this means pi is irrational, but 22 by 7 or 3.4 both are rational number.
Yes, sir. Clear.
Now let us move to next question. Next question is, the number 5 is a real number. Yes, as I told you that real number are nothing but grandfather of all numbers. It contains all type of number, natural, whole, integer, rational, irrational, and 5 is nothing but a natural number. So yes, 5 is a real number. Next question is, the product of two irrational number is always irrational. So why the product of two irrational? Let us try to solve using some example. Let me first rub the board. Why product of two irrational is irrational? Suppose we have two irrational number, root 2 and root 3. When I multiply these two irrational numbers, it becomes root 6, and root 6 is again an irrational number. So that is why we can conclude that the product of two irrational number is irrational number. Now let us take one question from our NCRT.
Sir,
Find.
Can we have an example where sum of two irrational numbers is rational also?
Sum of two rational.
Irrational.
Some of two irrational are rational. Yes, we have an example for this. Very good question. How we can say that sum of two irrational?
Similarly, the product of two
sum of two irrational is rational.
Yes.
So let us consider an example of root 2 and minus root 2. Root 2 and minus root 2 both are irrational number. But when we add these two terms, root 2 plus minus root 2, we will get 0. And 0 is what? A rational number.
Sir, can we have product also, product of two irrational numbers equal to rational number? Can we have examples of such?
In case of product of two irrational number, and root 2 and minus root 2, so it is minus root 2 into root 2, which is minus 2. So yes, product of two irrational number is also a rational number. Now let us move to next question from our NCERT. Find 5 rational numbers between 1 by 2 and 1 by 3. Find 5 rational numbers between 1 by 2 and 1 by 3. We have already solved such type of questions in our class 8th. So what we are going to do in this type of questions, or how we are going to solve this? To find 5 rational number between these two numbers, we first need to make their denominator same. So for this we have to multiply this 1 by 2, multiply and divide this 1 by 2 by 3, and this 1 by 3 by 2. So it becomes 3 by 6 and 2 by 6. Now to find 5 irrational number, what we need to do? We need to multiply a number which is greater than 5 with these two fractions. Let us multiply and divide 10 in both the cases. Finally it becomes 30 by 60 and 20 by 60. So the numbers between 20 by 60 and 30 by 60 are 21 by 60, 22 by 60, 23 by 60, 24 by 60, 25 by 60. So that is how we can find two rational or more rational number between two rational numbers. We have one more way to find such questions, which is more easier to this concept. As we know, the definition for rational numbers are non-terminating but repeating, or just terminating numbers. So let us try to use this definition. If we convert this 1 by 2 into decimal form, this 1 by 2 is nothing but 0.5, and similarly this 1.3 is 0.3 bar. And we know the number between 0.2 and 0.3, which are non-terminating but repeating in nature, or just non-terminating numbers, terminating numbers. Such numbers are rational numbers. So I simply took 0.3, 0.5, I simply took 0.4. This 0.4 is a rational number. 0.41 again a rational number. 0.42, 0.43, 0.44. So that is how we can write infinite rational numbers between two rational numbers. So from this you can infer that we have infinite rational number between two rational numbers. Similarly, we have infinite irrational numbers between two rational numbers. So that is how we are going to solve these questions. So similarly, we will do some more concept or some more topics from this chapter. That is, we are going in our further classes we are going to solve how to convert decimal rational number into p by q form, how to plot a rational number on number line. We are also trying. We will also solve questions from worksheet side by side. And after completion of this chapter, we will solve some hot questions from worksheet. Our worksheet is very important. You have to do all questions from worksheet time by time. In classes, we are going to solve. We are going to finish this chapter, and on 13th class, you have your test. So be prepared for it. Thank you. That is all for today.
Thank you, sir.